We're carrying on with our paper 2 that we've been working through. So we've done questions 1 to 18. We're going to kick off with question 19 today. Same story. We are doing mixed topics, and whatever we get to, that's what we do. So looking at question 19, make x the subject of the formula y equals square root of x squared plus 1. So we need to rearrange, and we need to shuffle things around so that x stands on its own. Because make x a subject means we have to have an x equals whatever else is on the other side. So we have y equals the square root of x squared plus 1. The first thing we need to do is get rid of that square root. So in order to do that, we're going to square it, because the opposite of a square root is squared. Do it to one side, do it to the other. So we have y squared equals x squared plus 1. Well, we don't want a 1 with an x squared because we want that x on its own. So next thing is to move that 1 over. So if we minus 1 from this side, we minus 1 from this side. So we get x squared equals y squared minus 1. So once we've got an x squared equals a y squared minus 1, we're very close to having x on its own. So what we need to do to reverse a square, we're going to square root. So we're going to square root this side, which means we're going to square root that side as well. So we would have x equals the square root of y squared minus 1. So here in our answer space, they've given us the x equals. So it is just square root y squared minus 1. Make sure that that square root goes all the way over to the very end. It's the whole side that you square rooted. So we kicked off with a bit of equations. What comes next? Something completely different. That's the wonder of past paperwork. So question 20. We have a diagram showing a speed-time graph. Okay? They asked us to calculate the total distance traveled. When we get these questions, there is one thing we do before we even start. We say that's a meters and that's a meters. Okay? We don't have to do anything worrying about changing things there. That is a seconds, and that is a seconds. So we've got consistent units being used throughout. We don't have to convert anything. We can just go ahead. The beauty of a speed time graph, of course, is that the total distance traveled is simply the area under the graph. So if we can calculate all of this area, then we have the distance traveled. So we can do triangle plus rectangle plus triangle, or we can just simply do area of 2 parallel sides, 2 not parallel, a trapezium. So area equals 1/2 a plus b h, just in case you needed a reminder. So area equals 1/2 a plus b, so our 2 parallel sides. So a, let's call this one a, it goes from 3 to 10, so that makes it a 7. That means this side here would be b, from 0 to 15, well, then it's a 15. And then our h is our perpendicular height, so perpendicular distance between the 2 parallel sides. So we're going from 0 up to 12, so our height is 12. So area equals 1/2 times 7 plus 15 gives us 22 times 12, which gives us 22 times 6, which gives us 132. So the answer then is 132 meters distance, because we're not giving the answer in terms of an area of units squared. We're using that idea that the area under the graph gives us a distance. So 132 meters is your total distance traveled. I'm just going to keep going, and if you have any major questions, then type quickly so that I know that I must pause and explain. Next one, question 21. The joy of vectors. So O is the origin, and K is a point on AB, so that AK to KB equals 2 to 1. So they haven't done that, so I'm going to add that in there. OA is vector A, and OB is little vector B. Okay, they are position vectors. They're going from the origin to the point. Find the position vector of K. So they want OK. Give your answer in terms of A and B in its simplest form. So that's a reminder that as you walk around this shape, you can only walk in the direction A or the direction B. So how are we going to get there? Well, OK is what we're looking for at the end of the day. So we need to start from O and we need to get to K. So let's just first see where it is. How would we do it in terms of big vectors? Well, we could walk from O to A. That's great. OA. Okay. Once we get to A, we've got to walk towards B. How much have we got to walk towards B? We've got to walk 2 out of 3. So, plus 2/3 AB. So actually, this isn't our walking instructions. Sorry, this is our vector instructions. Okay, so we're going to walk from O to A. Then we're going to walk from A to B, but we're going to stop 2/3 along it. So that's great. OA, we know. That is little a. Plus 2/3, but we don't know vector AB. But we can get there. How would we walk from A to B along our little ABs? Well, from A, we could go back to O. So that would be minus A. And then we can go from O to B. So plus little b. So now we've got A minus 2/3 A plus 2/3 B. Well, A minus 2/3 A would be 1/3 A left plus 2/3 of B. So when it comes to vectors, you've got to think about where would I like to go, and then how am I going to walk along my A's and B's to get there. So it does help to scribble on the diagrams as well and actually draw your walking path in, because then if you start walking up here and then you think, nope, can't do that, okay, I must walk along my A's and B's. And then you can just simplify all of your little walkings down into one final answer. So our final answer would be 1/3 of A plus 2/3 of B. And just, why am I underlining? Remember, it's vectors. They can write them in bold, but we can't write in bold. So whenever we are writing out our vectors, we're going to underline them so that they know that we're talking about the vector A, not the variable A. Okay, so a little nice revision of vectors. A little walk around the triangle. What comes next when we turn the page? A collection of angles. So a whole lot of angle facts to work with. So first off, we take a good look at our diagram and our information. We want to get familiar with this circle and its collection of lines before we start trying to calculate anything. Okay, so A, B, C, and D are points on the circle center O. A, B, C, D, cool, they're all on the circumference. B, C, E is a straight line, okay. AOC is 108, and DCE is 60. Cool, we're happy with all of that. Calculate the values of W, X, and Y. So now we need to have a little bit of a think. Okay, what information can we use, and what information have we got? So where could we start? When I look at this, I actually like to start. Oh gosh, we've got some fun ways of getting around this. Okay, so I like to start actually with X on this one. Makes the most sense to me, because we know that an angle that we make here is half of the angle at the center. Okay, so the angle at the center here would be 360 minus 108. And this angle here in the other segment, other sector, sorry. No, it is a segment. sorry, I'm going to draw some more things on here because I like to be very visual with these. So we have then the chord AC. Okay, so we have here a minor segment and here a major segment. So when we have a chord AC, the vector, see I'm getting stuck on the last question. The angle here, subtended, is half of the angle in the other side. So for angle X, we would need 360 minus 108 over 2. So if you're also working on this question simultaneously and you've got another root, that's absolutely fine, as long as you get the same answer as me, that X equals 126. So X is 126. So now we know this is 126. And this was 360 minus 108, which gives us 252, just in case we need it again. Okay, so now we're going to take out our AC because we're done with working with him for those two. Who are we going to do next? Well, in my brain, what makes sense now is to do W. Okay, because I can see a shape here. Let's change color. I can see A, B, C, D. Okay, cyclic quadrilateral. Which that means then that A, B, C, D, our opposite angles here are supplementary. So W is going to equal 180 minus 54. Minus 126, sorry. Minus 126, which is going to give us 54. Okay, so opposite angles there. One supplementary, 180. So 126 of our X, then W must be 54. Okay, so now we add in our 54 there. How are we going to get Y? So let's look quickly. Okay, again, we're going to take out our yellow so that we can see quickly where Y is sitting. So Y is sitting within here. Okay, so how are we going to get Y? Well, the beauty is that Y is also opposite this angle here. Okay, so if we can get this angle here, then we would be supplementary. But remember, there is another thing. If there's a supplementary across, then obviously the exterior angle is going to be equal. So Y is going to be equal to the 60 degrees that we actually haven't used yet. So, oopsie daisy, I didn't want to turn them all blue. Sorry. Okay. Okay, so Y is going to be 60. Okay, so 60 plus 120 would give us 180. 180 minus 120 would take us back to 60. So Y is going to be 60 degrees. So we've also had a few things come through on this one. So obviously people's brains look different to mine. So we have the question of, do we need to write the reasons in the calculations? Not for this question. If there is a question where they want you to give reasons, they would say, find the value of X, X equals blah, because, and then you would give your reason. Okay, can you also use the bow tie method? Yes, bow tie methods are wonderful to use as well. So we would have had 108 over 2 because we have an angle at a center versus an angle on a circumference. So we have, how is Y 60 degrees? Okay, so that, remember, here we have a straight line. So 60 plus 120 gives us 180 for this full angle. And Y is opposite that 120. So it must be supplementary, which makes it 180 minus 120, which is 60. Okay. Also, you have that rule of interior is exterior on the opposite corner. Also, you could say 360 minus everything included, then you would get the 60. Okay. Should you include these reasons if it's not asked? You can include the reasons because it can be nice to think, oh my goodness, when you come back to this and you're looking back at it later and say, how did I do that? Why did I say that? Then If you've got the reason there, you can follow your thought pattern. So there's nothing wrong with giving extra information. Okay? So as long as you're being nice and concise and not taking up a huge amount of your time as you write out essays, okay? So use a shorthand notation so that you've got the reason there. But at the end of the day, they didn't ask for it, so it's your personal preference whether you're going to include it or not on this question. Okay, so from angles to something slightly different. Angle again. The diagram shows the sector of a circle, center O, and radius 6 centimeters. The sector angle is 30 degrees. The area of the shaded segment is k pi minus c centimeters squared, where k and c are integers, which means, of course, they just have number values. Find the value of k and the value of c. Well, we need to figure that out. So area of a shaded segment. Well, how would we actually go about calculating it? We would have to say, you know, the area of that sector minus the area of this triangle, okay? The whole area of this sector minus the area of this beautifully white triangle would give us then the shaded area. And if we work through that, hopefully we're going to get something that's going to be related to K and C. We should do, because we should then get an answer for the area of the segment. And we should be able to compare to see K and C. So the area of a segment equals area of the sector minus area of the triangle. Okay, so area of the sector, we would need a fraction of the area of a circle. So our fraction here is going to be 30 over 360 times area of the circle is pi r squared. So pi r squared is going to be 6 squared. Okay, minus the area of a triangle. We don't have half base times height for this one. So we're looking, how else do we do area of a triangle? Our sine rule. Okay, sine for the area of a triangle, 1/2 AB sine C, where C is the included angle. And remember, these are radii, and this is also 6. So 1/2 A will be 6, B will be 6, okay, there's A and B, and then C at O. So sine 30. That's going to give us the area of that triangle. So now if we simplify and do some calculations, 30 over 360 times 36, and then we're going to leave that pi alone. Okay, we're going to put him into a calculator as a pi, and he's going to be spat out as a pi, because we want that precision. So this simplifies to 3 pi. And 1/2 times 6 again, times sine of 30. You can put all of that into your calculator at once. Gives us minus, that it actually comes out as a 9. So the area of the segment is 3 pi minus 9. Now we compare it to theirs, and we can say, the coefficient of pi is k, which is 3. So k equals 3. The number on its own is the c, minus c, so minus 9, so c equals 9. So k equals 3, c equals 9, just from comparing our answer to theirs. Let's move on to some equations. Solving equations, 7 minus 3n equals 11n plus 2. So we need to move some things across. Nice to have positive n's. So plus 3n on both sides. And we would have 7 left alone equals 14n plus 2. Well, we want n on its own, so we get rid of the 2, minus 2 on both sides. 7 minus 2 gives us 5, equals 14n. Well, we don't want 14 n's, we want only one of them. So we divide by 14. So n equals 5 over 14. It's a simple fraction. It's not going to go anywhere else. So n equals 5 over 14. Similar story with part B. Okay, first thing we want to do is get rid of that fraction. So we're going to multiply through by the LCD. There is only one. So we're going to multiply through by 5. Do the same thing to both sides. So on the left-hand side, they cancel beautifully. P minus 3 equals 3 times 5 gives us 15. Okay, then we're going to plus 3 because we want to get rid of that 3. We don't want it with P. So P equals 15 plus 3 is 18. So P equals 18. So, next one. Factorize completely. Completely. So, first one, quadratic. Ax squared plus bx plus c. We're going to have to go for 2 brackets. So, we are looking for factors of 132 that subtract to give us 1. So, 1 and 132, we are miles away. 2 and 66, we are miles away. But we think, hold on, 11 times 11. 11 squared, 121. Haha, 11 and 12. 11 times 12 is 132, and the difference between 11 and 12 is 1. Okay, so x and x. So we know that our numbers are 12 and 11. We know we need different signs because we have minus 132. So then we look at this sign and we say, the bigger one should be negative. So who's bigger out of 12 and 11? It is 12. So minus 12 plus 11. With these ones, it always check. X times x gives us x squared. Yay, we're happy. Minus 12x plus 11x gives us minus x. Brilliant. Minus 12 times plus 11 gives us minus 132. So x minus 12, x plus 11. The next one, x cubed minus 4x. Well, we don't have a way that we do our x cubed. So we're looking now just at straightforward normal factorization. We're looking for something common and we're taking it out. Well, there's an x in both. So let's get rid of him. X squared is left from x cubed and minus 4. But we don't stop there, because that is one of those funky relationship patterns that we want to be familiar with. This is the difference between 2 squares. So x plus 2, x minus 2. So when we factorize completely, we're left with x plus 2, x minus 2. And that's why they've said that you must factorize completely for these questions, because we must take it all the way. So question 26. Working in 3D. Brilliant. What do we got? We got a diagram showing a prism of length 4 centimeters. Cross section in a right angle triangle. BC equals 3 and CQ equals 2. Calculate the angle between the line AQ and the base ABCD. So remember what I said. These ones you want to pull out your triangle. So between AQ and BCD. So it's this angle here. So the triangle we want to work with is QAC. This is the angle we want. We can see we've got that 2. QC is 2, but we don't have AC. So now we've got to first say, okay, what is AC? So if we draw AC across there, we can see we had a square base. So that's a right angle. So we have got 3, 4, right angle, hypotenuse. So we know that AC squared equals 4 squared plus 3 squared. So AC squared equals 25, 16 plus 9. So AC equals 5. So now we can go to this triangle and say AC equals 5. That is beautiful. Now we've got 2 sides. Remember, this one is also a right angle. 2 sides, unknown angle. We've used Pythagoras. Where are we heading towards? We're heading towards SOHCAHTOA. So who have we got? We've got opposite and we've got adjacent. So if we think of SOHCAHTOA, opposite and adjacent belong to tan. So if we call our angle x, because we need something to call him, we can say tan x equals opposite over adjacent. So then for x is going to equal tan to the minus 1, 2 over 5. And we plug that into a calculator. Can't do that in our heads. X equals 21.8 degrees. So the angle between the line AQ and the base ABCD is 21.8 degrees. We always give angles in degrees to 1 decimal place. And we move on to the very last question of this paper. Question 27. So I'm working with indices. They ask us now to simplify 81 to the 3 over 4. You can just plug it into your calculator. If you wanted to break it down a little bit, we would want the 4th root of 81, okay, and that is 3, and then that would be cubed. And 3 cubed equals 27. X to the 2 over 3 divided x to the minus 4 over 3. Now that you can't plug into your calculator. But remember that when you divide, you subtract those indices. So we would have x to the 2 over 3 minus 4 over 3. So then we would have x to the 2 over 3 plus 4 over 3, which is x to the same denominator, so we can just add the numerators, 6 over 3, and that we can simplify. X to the 6 divided by 3 is 2. So all of that yucky mess is actually, very simply, x squared. Much nicer. And the very, very last one, 8 over y to the 6 to the minus a third. Remember that minus a third must be put onto both. So we would have 8 to the minus a third over y to the 6. Remember, when we're putting on an exponent again, it will be times minus a third. So this would then be 8 to the minus a third. Well, that 3 is a cube root. Cube root of 8 is 2. So we have 2 to the minus 1 over y to the 6 times minus a third is minus 2. They like the 6's and 3's for this question. So we don't want to leave it like that with those negative exponents. Remember, the negative exponent just flips you to the other side of the fraction. So we would have, the 2 would go down. It would be 2 to the 1, so we leave the 1 out. And the y would come up to be y squared. So we would have y squared over 2, or half y squared for that final one. A few more steps. So you do get 2 marks for that one. But it is really important to be comfortable with all your laws of indices, because it's not something that you can always just calculate with a calculator. You do have variables in there, and you need to understand how the indices work when you've got those variables as well.